I know a little bit more about what the next speaker is going to speak about, and she has studied robotics for 20 years. She is a professor at KTH, and she knows more about robotics than anybody else. She is Danica Kragic. Welcome, stage is yours.
Hey, hello. So let's see if it comes up. Yeah, so I got 10 minutes to tell you everything about the history of robotics and the future of robots and, of course, mankind. Well, robots have been around for a really, really long time, if not in our physical life, then in our dreams. And going back to Leonardo da Vinci and some people, even before him, people have been drawing machines that can, well, take over some of the dirty, dull, and dangerous jobs that we humans are doing or supposed to do. Now today, robots are everywhere, and AI is also everywhere. And what we're seeing is that it's transforming basically every business around us. So we have robots in the classical assembly industry, putting together phones and cars. But also, what we are seeing today is that robotics devices can be used to be dispatched to areas which are dangerous for humans, for example. And the dream is also that in the future, we will have robots that can be used as our companions. So one of the examples, let's see if all three of these, well, only two of them should play, that's fine. So vision that ABB has, they started to build a robot that resembles or is inspired by human appearance, so it has two arms. And the idea for the future is that at work, there is a robot and a human sitting side by side, having a human doing the things human is good at, and having robots doing the things robots are good at. But we also see a lot of potential for having robots doing collaborative tasks with humans. So helping humans to carry heavy things around, or only robots doing that. And also having robots being human caretakers. And when we talk about collaboration, physical collaboration about humans and, or between humans and robots, there are still many things to be addressed, both for those building robots and for us researchers developing AI and reasoning techniques that make robots intelligent. So the speaker before me said that there will be a need for somebody making robots shiny because they are and will be made out of metal. And this is one of the big questions. How do we make robots that are soft in the future? Because when there is a requirement for, as I said, physical interaction with humans, the metal will actually need to be questioned. Now, I recorded this video a couple of weeks ago with my postdoc, and I told him that he should be making a dove. And it's obviously that this is a task he never did before. He doesn't have the slightest idea what he's doing. But he's putting together ingredients, and he's doing his best in getting this dove working. But the idea was that we should build or make an inspirational video showing how we would like to have robots in the future, anticipating and helping humans in their daily business. So the robots should have the ability to observe the scene, so Francisco in this case making the dove, and understand what are the ingredients that Francisco needs more of. And this is exactly what when you sometimes do this, you would like to have a third hand, right, to interact with the things around you. And this is just one example. There are very many examples in the industry, regular industry, where we would like robots to interact with humans and anticipate. So have the understanding of the task that the human is executing and being there proactively interacting with the human. So there are very many challenges. So this is one way of human-robot collaboration. And we humans collaborate on a daily basis. And studying humans and human collaboration can also help us to develop future robotic systems that are then exchanging humans in some way. But even for humans, things do not happen very fast. So I just have one example here. Let me see if this plays, showing you what has happened during 60 years in a pit stop of Formula 1, okay? So on the left-hand side, you have an example from 50s. So exchanging a tire has taken 2-3 minutes, and this is what I call dirty, dull, and dangerous job. I don't think that this guy really had really fun at work every day. But what has happened during 60 years? Well, the tools got better. The process of exchanging tires got better, so who is doing what, planning got better. But the interesting thing here is there is really no job loss, right? We have more people in the pit stop of Formula One today, even with all the gadgets that are available, than we had back in 50s. But what can we learn from this collaboration? What can robots do that humans can? So we read about AI, robotics on a daily basis, and we know that we can build machines that are much better than humans in playing games, for example. So if we know something about the rules, if we know something about the world that the machine is supposed to act in, it's like a calculator, you know. It can execute, or it can estimate the best next move much faster than the human brain. But what is still hard today is having a robot actually physically playing chess with a human, detecting the chess pieces and using its own body to interact and move the pieces around. So there are no robots in the world that can do this in a general manner today. There is also a lot of talk about cognitive agents. So there has been a talk about VR and how in the future we can interact with virtual agents that can, like a fur hat here, which I don't consider to be completely a robot. But anyway, so having virtual agents, having and conducting a dialogue with a human. There is lots of development in terms of understanding human dialogue, natural human dialogue, and also doing this on very many different languages and so on, both for, let's say, interacting with the banking business and having a virtual agent that talks to you, but also from the purpose of kind of like teaching humans how to execute certain tasks. Now, what an interesting thing is that today we can or have better and better understanding of natural language. And what is, in this case, claimed for Amelia, that Amelia can actually comprehend the underlying meanings, so the things that are not being said. And I said, wow, that's fantastic, because not even my husband can do that. It's a definitely difficult thing, just from dialogue. But there is actually a very big challenge here, because when we talk to each other, it's not only the dialogue that we use to understand each other's behavior or state of mind. Very much of the things that we are saying and conveying is also in our body. So understanding the body movement affects very much what the meaning of the things being said also is. I'm not going to say anything about Sophia. For those interested, there is lots of development in terms of building robots that are very human-like, that have facial expressions, and that can also conduct the dialogue. So going into the physical, from virtual to physical, is actually happening where we speak. Now, there are definitely big challenges. And this is that in many cases, when we conduct dialogue, we do have some form of context understanding. We do have the experience of being in a situation like this before. We know who we talk to. And all this information is used to convey and conduct the dialogue. Having robots with experiences and really understanding the meaning of what is being said and using this information before acting is extremely important. Because when it comes to safety, one of the things that we are very good in is when a human acts wrong, we have a very easy time, in most cases, forgiving a human if that human says, "Oh, I'm really sorry, I didn't understand what you meant." How will we act when a robot says, "Oh, I'm really sorry, for hurting you. I really didn't mean to. I didn't understand what you say." And I think that we will have much more difficult time as humans to forgive robotic systems. Now, how do robots learn today, and what are the trends in teaching robots how to learn more and how to then get the experience that is human-like, in the same way as humans do. So this is just one of the examples from the project that I was involved in for the past 5 years. And it's about teaching robots how to do human-like tasks from knowledge that has been generated for and by humans. So if you're supposed to, I don't know, prepare a dinner for somebody and you're trying really to impress them and prepare something that you haven't prepared before, what do? You Google for a recipe on the web, right? You get the recipe, the text instruction, what ingredients you need and how you put them together and so on. You read that and you basically plan your activities based on that. And then if you don't really know how to physically use one of the ingredients or prepare a very complex cake, you will be YouTubing for a video. So you will be looking for a video instruction. And this is exactly what we do today, using the information then that is out there, Wikipedia and Google and YouTube and so on, where the robots can then extract the knowledge from the knowledge that is available then for humans. Now, there are very many big questions there. So how do robots transfer the motion, the actual physical motion? Because robot body is still very different from a human body. It doesn't have the same kinematic and dynamic properties. What needs to be learned? For example, when it says in the text, crack an egg, and then you look into a YouTube video of somebody cracking an egg, what's really important? How do you explain or how do you build a program in an unsupervised manner that actually generates then robot motion that cracks an egg in a proper way? And when should robots learn? So what is a good example? What is a bad example? And I think that with lots of examples of Twitter robots and so on, it's very common that people that test them and want to joke with robots, they're also using very many negative examples just to see how smart a robot is. So what is important is also the education. How do we educate ourselves, but also our kids? What is the proper use of the technology that is available out there? Interaction with the world is not so easy, and in order to be able to program robots to do this effectively or as effectively as humans, we also need to understand a human. And well, still large portions of the brain are unknown. Something that we know is that it takes more mental power to use your hands than the rest of the body. This is just one of the pictures showing that, how much of the brain energy or mental power you need to control your hands or your tongue. And understanding of a human can then, and the brain structure can help us to use the algorithmic structures like deep learning and so on to build robots that, to some extent, are resembling humans. Now, the challenge for the future and what robots can't do today, these are just some examples of robots that I have in my lab, one of them, and the other is from Boston Dynamics. The video on the upper right, it's called washing dishes. Really, for me, this is not washing dishes. This is just basically putting things in the dishwasher. And the Amazon company is now looking also for a solution for having a robot filling and emptying shelves, packaging things that you put that you order over the web and so on. Now, I'm supposed to say also what robots can't do today, so I wanted to make a relation with this two images, and this is extremely difficult. Let's see if this one plays. Hopefully. Oh. No, anyway, what you would see in the video here is actually a human washing dishes. So using a sponge, interacting with different types of objects, putting the powder on the dishwashing powder on the objects and so on, and being able to actually use very high dexterity of the hands and not break any of the objects. Now, this is still a difficult task for very many humans. My husband, again, says this is an impossible task for him. But this is the biggest challenge that all the robotics community is looking at today. How to develop robots that resemble human hand dexterity and that can interact with any type of object, independent of whether we interact with objects in air, in water, in oil, and so on. So there is still a lot to be done. I'm done.
Thank you very much. Thank you very much, Danica. That was brilliant.
Thank you.
And what I think is wonderful to have somebody that really, really knows something deeply about something is that you can just keep asking questions and keep understanding things, not on a PowerPoint level, but actually digging deep. So if you're interested in robotics, this is who to speak to. Thank you very much.
Thank you so much. Thank you.